Now that we've talked about different developmental theories, we can talk about general research designs. Specifically, we'll talk about correlational designs and experimental designs. Let's start with correlational. Correlational designs measure how people score on two variables. For example, we might measure how an individual scores on GPA and ACT scores. We would then calculate a correlation coefficient, which is R, between the two variables' scores. This value simply tells us how much those two variables relate to each other. R's can range between -1 and +1. R's magnitude shows how much the scores on one variable can predict the other variable's scores, regardless of the sign. So the closer you are to 1, the better prediction you have. R's sign indicates whether the relationship is positive or negative. If it's a positive relationship, it means both variables move in the same direction. For example, when you have increases in GPA, you typically also see increases in ACT scores. Or when you have decreases in GPA, you typically also see decreases in ACT scores. If R is negative, it means that the variables move in opposite directions. An example of this would be class absences and overall grade in the course. As absences increase, typically grade in the course will decrease. One thing that's critical to remember is that correlation does not imply causation. It could be that there is a causal relationship between the two variables, but just because two variables are correlated does not mean that one causes the other. So, it could be that variable A causes variable B. It could be that variable B causes variable A, or it could be that we see a correlational relationship between variable A and variable B because of a third variable not measured in the study. Here's an example. Let's say we see there's a correlation between being smart and having more friends. This simply means that there's a relationship between intelligence and having friends. So, it could be that being smart causes you to have more friends, right here. It could be that having more friends causes you to be smarter. Or it could be that there's a third variable that was not measured in the study, such as parents. It could be that parents who are warm and supportive tend to have children who are smart and children who have more friends. So remember, correlation does not imply causation. It simply tells us whether or not two variables are related. The second type of general research design are experimental designs. Experimental studies involve systematically manipulating key factors that the investigator thinks cause a particular behavior. So the factors being changed are the independent variables. The independent variable is the variable being manipulated. The dependent variable is the behavior being observed. It's the effect or the outcome. So if I'm interested in the effect of stress on sleep, can you identify what the independent variable would be? Did you say stress? That's correct. Can you identify the dependent variable? It would be sleep. So think about, how could I design a study to answer my research question? Well, I would manipulate the levels of the independent variable. I would manipulate stress levels. So, experiments typically include an experimental group, or the group of participants who receive the independent variable. They also would include the control group, or the group of participants who receive a placebo or no treatment. So in this example, maybe my experimental group are the group of participants who have stressed out. Maybe I tell them, in the morning you'll have to prepare a 10-minute speech for me on the topic of geology. Then the control group would be the group that I do not stress out. When trying to study cause and effect, it's very important to randomly assign participants to either the experimental or the control group. So, when you're trying to study cause and effect between two variables, really the only way to do this is experimentally, with an experimental design. You would first manipulate exposure to different levels of an independent variable. After exposure to the independent variable, you would measure how people score on a dependent variable. The main question is whether the dependent variable's scores differ depending upon the level of the independent variable.